All right, so in 4.4, we're learning about least common multiple. All right, now in 4.2, we learn about greatest common factor, the biggest number that goes into two or more numbers. Now with least common multiple, we're looking for the smallest number that is a product of two numbers. Okay, so a multiple is actually a product. Whenever I multiply a number by another number, the answer, that's what I call a multiple. Okay, so in example 2, it tells us to find the least common multiples of 7 and 8. Well, instead of listing factors here, I'm going to list their multiples. So the first multiple of 7 is 7. The next one is 14. The next one is 21. What comes next? 28. 35. 42. 49, 56, 63, and 70. Now, as I'm listing out the multiples, I'm keeping in mind my other number, 8. And I'm asking myself, okay, 8 doesn't go into 7, 8 doesn't go into 14, doesn't go into 21. So as I'm listing them, I'm asking myself those questions. But you still have to list out the multiples of 8. So 8, we go 8, 16, 24, 32, 40, 48, 56, 64. Okay, well, did I hit a number that was common? Yes. What was it? 56. So my least common multiple is 56. Okay, so finding LCM by listing multiples. All right, now that's different from factors. Factors are numbers that go into a number. Multiples are products of a number, okay? Now I want you to do one on your own. I want you to do 2, 6, and 14. 2, 6, and 14. Okay, so whenever you're finding LCM by listing multiples, always start with the biggest number, because along the way you can ask yourself if the other numbers can go into it. Okay, so for 14, the first multiple is 14. Does 2 go into 14? Yeah, but does 6? No, it doesn't. So I'm going to keep going. What about 28? Does 6 go into it? No. So I need to keep going. What about 42? Yes, it does. 6 goes into it, and does 2 go into it? Yes. So 42 is going to be my LCM. Now here's the bad news. The bad news is that you still have to list the multiples of the other numbers. But you know that 42 is the LCM, so you don't have to go past it. So, yeah. Oh, my first 14 disappeared. Okay, so 42 is your LCM. LCM equals 42. Now, the good news is, too, on test, it's only going to be prime factorization. All right, now in example 3, this is going to be more along the lines of what you would see on a quiz or a test. Find the LCM of 84 and 360. And 360 using prime factorization. 84 and 360 using prime factorization. Well, here's the good news. You already know how to do prime factorization, right? Okay, so go ahead and do the prime factorization of these two numbers. All right, so now that you have the prime factorization, you've done the prime factorization, does y'all's match this? For 84, do you have 2 times 2 times 3 times 7? Yes. For 360, do you have 2 3 times 3 twice and a 5? No. Okay, well if you don't, you did something wrong, okay? So make sure it matches up. So now that you have the prime factorization, list off your prime factors least to greatest. So for 84, we have 2 times 2 times 3 times 7. For 360, we have 2 times 2 times 2 times 3 times 3 times 5. Now, the same thing applies up to this point. This is the same thing as what we would do with GCF. Okay, and now we're going to group off our common factors. So what's a factor that both of these numbers have in common? Kenzie? 2. What's another factor? Class?
3.
3. We have some 3s here. What else?
2.
And 2. So under the LCM, you're going to write 2 times 2 times 3. But you're not done. For the GCF, this is where we would end, and we would say GCF is 12. But for LCM, we have to include the numbers that are left over. We have a 7, a 2, a 3, and a 5. And so now we're going to multiply those in as well. Times 7, times 2, times 3, times 5. In your calculators, what number do you end up with? Jessica? 2,520. And that is your LCM. Okay? So, up until what we have written in green, it's the same thing as GCF. Actually, what is the GCF? What did we just say? What is the GCF, class? The GCF is 12. So with the same two numbers, you can find the GCF and the LCM. The LCM just has another step right there at the end. All right, now I want you to find the LCM of 24 and 30 using prime factorization, just like we just did. The LCM of 24 and 30 using prime factorization. All right, so let's do the prime factorization. 2, 12. Okay, now we're going to list out our prime factors. 2 times 2 times 2 times 3, and then 2 times 3 times 5. All right, now we still group off our common numbers. We have a group of 2s and a group of 3s. So our GCF would be what? 6, because I multiply my groups together. 2 times 3 is 6. And then my LCM, remember I still write down for each group, I still write it once. Some of you made the mistake of writing it twice. Remember, for each group, you only write it once, and then you add in your leftovers. You bring them in. So now we have a 2, and a 5, times 2 times 2 times, oh, I'm sorry, that should have been a 3. Two times 3 times 2 times 2 times 5, and your LCM is what? 120. Good job, guys. But what if you had 3 numbers? What if you had 20? That's fine. 22 and 55. Okay, so now you have the prime factorization listed out. Do you have this? For 20, do you have 2 times 2 times 5? For 22, 2 times 11, and for 55, 5 times 11. Do you have that? Okay, now here's where it's different for LCM. Trevor, do you remember?
You circle the 2s and then you circle the 11, and then circle the 5s.
Okay, it only, for the factors to count as a group, the number only has to be in 2 out of the 3 numbers. Okay, this is a part of the video you might want to go back and rewatch tonight when you're doing your homework. So, because of that, what groups do I have? It only has to be in 2 of them. What groups do I have, Stephen? I have 2s, I have 11s, and I have 5s. And I'm just going to Just kind of weave through and circle my 5s. And then in my LCM, I'm going to write, for each group, I write it 1 time, 2 times 5 times 11. Am I done?
No.
What am I forgetting?
Times 2.
Bring in my leftover number, times 2. And what's my LCM?
220.
My LCM is 220. Okay? If you understand that, that's everything you need to know for 4.4.